This is R.D. Sharma solution, class 12, chapter 9, continuity. Exercise is 9.2. In the following, determine the value of constant involved in the definition so that the given function is continuous. So what do we do here? Because x, both are here, and we'll take the limit and we'll just equate it to the other value which is at x equals 0. Okay. Left hand limit and right hand limit also you can find out, and then you can place it and equate it. So the point of check is x equals 0. So we have to go on the left hand side and the right hand side. So on left it will be k into x square plus 3x. On right it is going to be cos 2x. So left we will put 0 minus h. Right we will put 0 plus h. Let us put it here. K 0 minus h means minus h whole square plus 3 into minus h. On right we have cos 2 into 0 plus h, that is h. Now k, since we have this h square plus minus 3h and we cannot get rid of this h anyways, so whatever you do, you have to put h as 0 when you apply the limit, and that is going to be 0 by itself. So the value which is having k as the content is becoming 0. On the right hand side, if cos 0 is taken, it is going to be, because cos 0 is 1. We are applying the limit here, limit h tends to 0. Cos 0 is going to be 1. So 0 is equal to 1. If LHL and RHL are equal, 0 is equal to 1, and we are not having k anywhere. So there does not exist any value of k which can make the given function continuous because of this contradiction or this inequality. Same thing we have to do here in the following. Determine the value of the constant involved in the definition so that the given function is continuous. So we have 2 points of check here, 3 and 5, and there are two constants here, 2 and 9, and ax plus b is having a variable x. So let me draw a number line, and it is 3 and 5. So 3 and 5 we have to check. So 3 LHL RHL for 3, that is the left hand side, right hand side. Similarly for 5 also LHL and RHL. And we'll get some equation. We are going to solve that equation. Okay. So let us start with x equals 3. And we have to put 3 minus h for LHL. And then 3 plus h on the RHL. Similarly for 5 also we'll do that thing. But let us complete this 3 first. So x is less than or equal to 3, it is already a constant, so we don't have to do anything for this. On right hand side it is ax plus b because it is going above 3. And a into x plus b, x you can write 3 plus h, and this is a 3 plus h plus b. So just put 0 here, or you can open it and then equate it, then put the 0. It's one and the same thing. So this ah will you can get rid of this ah. So 2 is equals 3a plus b. So 3a plus b equals 2. This is your first equation. And we are thinking on the right path because we are going to get an equation for x equals 5 as well. Same thing we have to do LHL and RHL. X is equal to 5. Okay. On the left hand side we are going to use ax plus b. On right we will be using this 9. 5 minus h, 5 plus h will put, but there is no point in writing anything or giving anything because it is a constant 9. Ax plus b, in place of x, just replace it by 5 minus h, and then you have to equate it by 9. So 5a, h is 0, plus b is equal to 9. So both ways we get equation on left hand side, means x at x equal to 3, and another equation for x equal to 5. What is the equation here? So we have 3a plus b equals 2 and 5a plus b equals 9. So let us write 5a plus b equals 9 first, and then 3a plus b equals 2. Subtract these two. bb gets cancelled. 5a minus 3a is 2a. 9 minus 2 is 7. A is equal to 7 by 2. Now you can put this 7 by 2 in any of these equations which we just got, and you will get the value of b. I'm placing it in 3a plus b equals 2. In place of a, I'm replacing it by 7 by 2. 21 by 2 plus b equals 2. b equals 2 minus 21 by 2. So you get 4 minus 21 by 2. So 4 minus 21 by 2 is actually negative 17 by 2. This is your b value. Okay. So a and b, this is how you will find out the values in another questions which are coming up. So in the following, determine the value of the constant involved in the definition so that the given function is continuous. So we have minus 1 here, 0 here, and we have one constant 4 and one polynomial and one trigonometric equation, the trigonometric value. Okay. So let us check it at minus 1 and then we'll check it at 0 because these are the point of check for continuity and discontinuity, and since it is given already, it is. So x equals minus 1. On left we will write minus 1 minus h. On right we'll use minus 1 plus h. Since we will use 4 on the left and right, we will use ax square plus b. There is no point in putting anything for 4 because it is already a constant. So don't worry about that. It will be always 4. It is a constant. In place of x square in ax square plus b, just replace it by minus 1 plus h. And this is ax square plus b. Now just open it and place h as 0. But you can also put it here. It won't affect. This is 0. Minus 1 whole square is 1 already. So a plus b. So first equation what we got from x equals minus 1 is a plus b equals 4. Now coming to x equals 0. Then on left we are going to use ax square plus b, and this cos x will use for the RHL. But we'll put 0 minus h for LHL. So ax square plus b, and on the right we'll put 0 plus h in cos x. This is minus h, so a minus h whole square plus b. So it is basically a h square plus b. So when you apply the limit h tends to 0, it is going to be 0. And you just have to write b on the LHL. So only b you got. On the right, it is going to be cos 0 plus h, that is cos h. And cos 0, when we apply the limit, what I am suggesting is we are applying limit also. That I am not writing, but you have to write it properly. So cos 0 is 1, so b is 1. So a plus 1 equals 4. I am putting b as 1. So a is 3. b is 1 and a is 3. This is your final result. Same thing we have to do here because the given function is continuous. It is given and you have to find out the value of the constant. What is the constant here? P. And we are in between minus 1 and 0 and 0 and 1. Okay. So we'll check for 0 here. And then we'll try to find out the LHL and RHL at 0. And the values are also given. That is the function value are given. So this is talking about 0, negative 1 and 1. If you have any confusion, just draw this number line. You will see where we have to check. Because here minus 1 below not given, plus 1 above not given. Only thing which we see is 0 left of 0 and right of 0. So x equal to 0 is the point of check. X will use as 0 minus h for left hand limit. For right hand limit we'll use x as 0 plus h. And the functions are, because basically it is minus h and h only. So we'll use this function. The only thing is that this function will need some simplification. So I'm writing it as a 1 because I'm replacing it by minus h. So it will be 1 plus px or 1 plus p into minus h. So it will be 1 minus ph. Similarly, minus under root 1 plus ph because we are replacing it by minus h. And in the denominator we have minus h. First let us complete this. So we have this, so let us rationalize it. So same thing, same numerator with a positive sign we are going to multiply in the numerator and denominator. So under root 1 minus h minus 1 plus ph, and minus h I am taking just to give a little bit of space. Under root 1 minus, same thing with plus sign, everything with same plus sign. But we have to multiply this in numerator as well and denominator as well, right? So once you do this, the numerator will be a minus b, a plus b. A minus b, a plus b is a squared minus b squared. And since it is root will get eliminated. you will get 1 minus pH minus 1 plus pH. Okay, this is numerator only I am doing. So 1 minus pH minus 1 minus pH. So 1 gets cancelled. You will get minus 2 pH. Since we have a negative H already there, you can cancel minus H minus H. So 2p is there. Okay. Since we have a 2p here, let us see the denominator, because some rationalization was done, let us put H0 here. So 0, this is 0, under root 1 is 1, under root 1 is 1, 1 plus 1 is 2. So this denominator gave us 2. Now you can cancel these 2. So you get P on the LHL. Now on the left hand limit you get P. Coming to the right hand limit. So we rationalize it. This is the only thing which will take some time. Right hand side it is 2x plus 1 by x minus 2. Just put h in place of x and just replace h by 0, applying the limit. H tends to 0. This you have to write, okay? I'm just not writing, just to save some time. So 1 by minus 2 you will get. Now you equate p with minus 1 by 2 because it is continuous. So left hand limit should be equal to right hand limit. So p is equal to negative 1 by 2, and that is your answer. This is your final answer. In the following, determine the value of the constant involved in the definition so that the given function is continuous. Same thing we have to do. We have two constants here, 5 and 21. And if you have any confusion, draw a number line. So this is 2. And you have x less than equal to 2, greater than 2. Then you have 10 as well. So now you have the value at for 2 below and above, 10 below and above. So you have to use 2 and 10 both points to get the relationship and solution, because we need 2, because there are 2 variables, you need 2 equations. So we'll start with 2 here, x equals 2. So 2 minus h will put here, 2 plus h will put here for LHL and RHL. You don't have to do anything here because it is already a constant 5. Yes, ax plus b in place of x, replace it by 2 plus h. So a 2 plus h plus b. Now apply the limit here. Limit h tends to 0, it will be 2a plus b. So you have first equation which you got is 2a plus b equals 5. This is your first equation. 2a plus b is 5. Now this second one, which is the point 10. So 10 minus h on the left hand side, 10 plus h on the right hand side, and 10 minus h will put it in ax plus b. So a 10 minus h in plus b. 10 plus h you cannot put anywhere because it is already a constant. 21, just keep it as 21. So apply the limit. It will be 10a, h is 0. So 10a plus b equals 21. This is your first equation. Second equation is 2a plus b equals 5. 2 equations are there. Now just subtract these 2 equations. bb gets cancelled. 10a minus 2a is 8a. 21 minus 5 is 16. So 21 minus 5 is 16. A is going to be 16 by 8. That is going to be 2. So a is 2. Now put it here. So 2 into 2 plus b equals 5. B is equal to 5 minus 4. That is going to be 1. So b is 1 and a is equal to 2. Right? So this is continuous. And the point of check is x equals pi by 2. And see, x equals pi by 2, 3 is already given. So rather than actually going through the left hand limit and right hand limit, we can very well see that the left hand limit or the right hand limit, only one computation is necessary. But you have to show the examiner that you are doing LHL, RHL both. Because pi by 2 minus h on the left hand side, pi by 2 plus h on the right hand side. So we'll use this function x less than pi by 2, k cos x, I'm replacing it by pi by 2 minus h, divided by pi minus 2 into, in place of x, just put pi by 2 minus h. On the right hand side, where it is not necessary, it is not required, but still you have to do 3 tan 2 into pi by 2 plus h, and then we have 2 into pi by 2 plus h minus pi. This you have to do, okay? But what I'm saying is, we can just get the answer by finding out the left hand limit only, because the left hand limit and right hand limit and the value of the function at x equals pi by 2, they will be same, because the question is already saying it is continuous. So k cos 90 minus theta is sin theta, just sin h. Now this is pi minus 2 into pi by 2 plus 2h. So this gets 2 gets cancelled, pi minus pi plus 2h, pi gets cancelled, you have 2h here. So sin h by h, you can directly apply the limit here. Sin theta by theta, limit theta tends to 0 is 1. So this is 1. I am applying the limit here. So sin theta by theta, sin h by h is going to be 1. So you get k by 2. Now this k by 2, the value of the function at pi by 2 is already given. It is 3. F pi by 2 is 3. So eventually k by 2 is equal to 3. So k gives you 3 into 2, 6. This is your final value. The function fx, you have x squared by a, you have a 2b squared minus 4b by x squared. And what are the points? So let us draw a number line and see what these points are denoting. And what are the points of check we have to do, for what we have to find out LHL and RHL. So let us see here. Actually it's more of a quadratic equation problem rather than this continuity. You'll see just now. So this is 0, this is 1, and root 2 is 1.414. So I am just writing root 2 here. And then we have infinity. So now we have a point 1 and root 2. So you have 2 points here. So x equals 1 you have to check, x equals root 2 you have to check. So 1 minus h it is, 1 plus h it is, because LHL and RHL you have to do. Here root 2 minus h you will put, and root 2 plus h. Root 2 minus h and root 2 plus h. Right. So there will be some relationship. That relationship will finally give you the value of the a and b. Okay, when you go on the left of 1, you have to use x square by a. So 1 minus h square by a you have to write. 1 plus h, it is already a constant a. So h, just apply the limit. Right, and RHL you don't have to apply any limit. Here h will be 0. So 1 by a, this is a. This will remain as a. So 1 by a is equal to a basically. So you will get a square as 1. So a square is 1. So a will be plus minus 1. So you are getting 2 values of a. What I am trying to suggest is LHL is equal to RHL. So a is 1 by a square equals 1. So a will be equal to plus minus 1. A will be under root 1, and always when you take the square, it can be minus and plus because it is even power. Now coming to the right hand side. And when you go on the left of root 2, you have to use a. So don't worry about putting root 2 minus h. Now coming on the right, you have to put root 2 plus h in this 2b square minus 4b by x square. 2b square minus 4b by x square. So x will be replaced by root 2 plus h whole square. Now root 2 plus h is actually 0. So root 2 whole square plus h square plus 2 into h. I am just opening root 2 plus h whole square. So wherever h is there, just apply the limit. Root 2 whole square is 2 only. So 2b square minus 4b, you can take 2 common from here. 2 into b square minus 2b. Since we have a 2 in the denominator, you can cancel these 2 out. So it will be only b square minus 2b, 2 gets cancelled in the denominator. I am just taking 2 outside. It will be b square minus 2b, 2 gets cancelled. Now b square minus 2b. What is the relationship? LHL, RHL. So b square minus 2b is equal to a. So a will be plus 1, a will be minus 1. What I am trying to suggest here is b square minus 2b is equal to a is plus minus 1. So we will get 2 equations here. B square minus 2b equals 1, b square minus 2b equals minus 1. So a was plus minus 1. A1 will take one time, a equals minus 1 will take another time. Since already this b is b square minus 2b equals a. So b square minus 2b, this is equal to 1. And b square minus 2b equals negative 1. So b square minus 2b minus 1, you will not get a proper relationship here. But here you can get factor b square minus 2b plus 1. So we can use the Sridharacharya formula anytime. But b square minus 2b plus 1 can be easily solved. B square minus b plus 1. You can take b common, b minus 1, and minus 1 common, b minus 1. Minus 1, I am just changing it to minus 1. And b minus 1 inside. Okay. So you have b minus 1 into b minus 1. That is b equals 1. b equals 1 is your one result. Now when you have this b square minus 2b minus 1, as I said, this is mainly a quadratic equation solution. So assume it to be ax square plus bx plus c. B will be equal to minus b plus minus under root b square minus 4ac by 2a. You know what to use for a, b, c. So I'm just writing those values, and this is 2. So you get 2 plus minus under root 4, 8. In place of 8 you can write 2 root 2. So just replace it by 2 plus minus under root 2 root 2 by 2. You can cancel 2. So 1 plus minus root 2 it will be. So one time it will be 1 plus root 2. One time it will be 1 minus root 2. So what do you see here? A is equal to 1. A equal to minus 1. B is equal to 1 plus minus root 2. Okay. So this is whole answer you have to write, because these are the suitable values for A and B. This question we'll take in the next discussion. Till then, thank you so much. Take care of yourself.